Good morning for everybody, and welcome to a short theory of tech debt. My name is Damian Malarczyk. I have over 8 years of experience working as a Django developer, and half of the time is spent on leading projects, especially as a solution architect, as I have spent a lot of time designing especially database solutions for solving particular problems. My main area of expertise is ecom and fintech industry. Last year, I have joined intive on December, and currently I'm working on an accounting application. Professionally, I am a big clean code enthusiast, and that is partially a reason for this presentation. And personally, I am passionate about bouldering and outdoor climbing and Warhammer fantasy. So before we get into the webinar, a few notes on the technical side of things. Here in Zoom, you will be able to raise questions in QA sections and vote on them. And at the end of the webinar, which will be around in 40 minutes or so, we'll be able to talk a little bit more about them. One note about agenda. You can see that we are in the info part. Next, we will discuss some definitions about what tech debt is and how to understand it. Then we will get to some categorization attempts, after which we will cover consequences and impact of the tech debt on our products. We will then follow with how to manage tech debt and what we can do, maybe not to resolve it, but just to how to work with it. And finally, we'll get to some summarization where I will also talk about bibliography. And maybe as a disclaimer, most of the knowledge here will be from the bibliographies, and I really encourage to review that later on. Okay, so let's talk a little bit about the financial tech debt itself. So, because that is kind of a debt that most of us understand how it works, right? But what it is actually? So that is basically a one-time boost that will have some long-term consequences. And why do we even take it? Well, usually that is to invest in profit. And the reason, the goal that we want to achieve is simply to profit on the boost enough to cover on those consequences. And technical debt is pretty much the same in construction, but it differs in a significant way. So it is still a short-term boost with long-term consequences. And the same thing is that we know what the boost is, usually. The difference is that we can't really measure consequences. So what are the types that, what were the attempts on trying to categorize what the tech debt is? So what you can see here is the study from Software Engineering Institute, but I'm sure it can be grouped in a lot of different ways. So what matters is that the tech debt is not really always about the technology. That term is a little bit obsolete, as the term tech debt was created 30 years ago. So it has a different meaning today. And it can occur in many areas. And like I said, not strictly technical. So what we will be talking about today can be generalized to more domains. One of the samples would be, for example, the process tech debt. We have some decision making, which simply involves too many people, and we are depending on those people because without their approval, we might not get the process done further. And the tech debt might be there is only one person that is like a bottleneck, and if he goes on PTO, then we will have to wait for 2 weeks to complete some process. Other not really tech-related debt could be the one that contains some people. Like, for example, we don't spend enough time on onboarding people to some project. We don't spend enough time to sharing knowledge. So there are people that are not fully oriented in the work they should be doing or the responsibilities. And similarly, other way around, we have people with a lot of experience, and we don't have a process to share this experience with others. So there is another approach how to categorize debt, and it's not by domain, but rather by its nature. What you can see here is a technical debt quadrant proposed by academics McConnell and Fowler, and they split debt to 4 categories. What you can see here on the x-axis is if the debt was taken recklessly or prudently, and on the y-axis, if it was taken inadvertently or deliberately. So let's go through each of them. Here you can see what we can call the best kind of debt. That's debt we take deliberately, and we know what are the consequences, or at least most of them. This is the simplest relation to a financial tech debt. We know there will be some cost, but we are confident that that the benefits are huge enough to explain taking this tech debt. However, there are other situations when we are kind of forced to make some decision without realizing, without having usually a time to check for the consequences, and that's reckless. And this is what I have found from experience often happens in startups where there is a very high pressure on providing any kind of profit from the product. So there's a pressure on everybody, not only on the engineers, to give anything without spending too much time on checking if that is a good direction or not. The next kind of debt is the one that gets more and more riskier, which is at some point we realize, oh, we have a tech debt, and we didn't know, we didn't even notice when it was taken. That could be, for example, for some lack of knowledge, especially the domain one. If we are working on some new area of technology, there is really there isn't really too much that we can that we can know about something, and well, only after a while we can come to realization that some decisions were made badly, and there is actually a tech debt that we didn't intend to take. And there is this worst kind of debt, which is we don't know we have taken it, and we never come to realization that it was taken. And there is more that we can talk about this one, because I think there is one especially connected citation about this. So comment made by Robert Martin, author of series of books on clean code. He says that mess is not a technical debt, that a mess is just a product of us being lazy or unprofessional. Adding a bad code to the system is not the tech debt, because that is not something that anybody on a clear mind would do, right? There is no pro in adding a code without any tests to the system. That's simply the well, unprofessionalism. And in my opinion, this relates strictly to that fourth quadrant. Because if somebody is simply lacking a skill or feels confident that he is alpha and omega on some subject, then that person may never realize that this could be done better, in a better way, if some different decisions were taken. However, on the other hand, if we have a situation that somebody is not handling a project well, then it may not be entirely fault of that particular person. Maybe it is fault of a manager that put too complex task on a person that doesn't have enough experience on working with that. So the mess may not necessarily be created by an engineer. Yeah, and some samples on the mess as well. So like deliberate usage of outdated technology, insufficient testing, or creating over complex code and procedures. These are stuff that never pay off. They never intend to pay off. So by Uncle Bob, they cannot be named debt. Now let's get into consequences of taking a tech debt. So usually it has two aspects, because as I said, it's not really measurable. There is some assured tech debt that we can, assured cost that we can kind of foresee. Like we will know that, okay, we may not fix this particular problem, but if we will do daily review of the alerts, then we can handle it that way. And so we expect to spend 30 minutes each day of our working time on this maintenance. Similar samples can be about restarting servers every week instead of trying to fix memory leakage, or having this extra approval in the process, because maybe cost of updating the process is so high that we accept the maintenance cost. And a lot of similar cases like this. But the other aspect is risks. And each debt can have multiple risks with it. If we have like a lot of code that we know is unstructured, that should have been written more to the solid principles, for example, there is a risk of increasing complexity every time we add a new piece of functionality to already complex code, right? So that will also bring a risk of diminishing returns. So we spend more and more hours on providing less and less business value. I think most common is the risk of unexpected failures. That is, for example, where we know that some particular component of our product is not stable, and it may produce well, unexpected results, unexpected failures, and that is kind of understandable in usual situations, like most of the web applications. But if we come to like physical manufacturers, the risk of unexpected failures is much more severe. And we'll talk about risks more in the next slides. But what is important to remember that there can be multiple risks per a single tech debt, and each of them will have its level of severity and probability of happening. And that in total is the cost of taking a debt. So we have this cost, but how does it impact our business? So let's assume for the purpose of this webinar that we are talking about mostly about software application, right? And but in general, in the core of each business, there will be some production piece. In this case, this will be code, but it's not the only piece of the company, right? That's only a core, and we have to put it always in the bigger picture. So with the code or the this most lower piece that creates a product, but there is also a team that works around it all, and business as a whole that spins all of this together, and is usually the most user customer faced part of the company. So whenever there is a debt taken within this core, it will start slowly impacting further and further. And in backs increasing complexity and falling quality will slowly degrade all other pieces of company like product, because the delivery time is slower and slower, and we are worried that our competition is doing work better and faster and is starting winning over us. From the team perspective, it could be impacting morale, because team can be overburdened with doing this maintenance on tech debt, or resolving bugs, or working with outdated technologies that are not really growing them as a professional developers. And in wider scope, that can cause retention. After all, nobody wants to work for legacy products forever, right? And putting all of that together, that will eventually impact business as well. If we have a bug that is a security concern and will not handle it on time, it may happen that we'll have a huge leakage of data. That happened many times, as we have heard of for past few years, like passwords leakages or accesses here and there. So that will definitely impact business strategically, sometimes leading even to a question if a company may survive or not, right? And this risk of survival started here at the core. So it's always worth remembering, we're talking about the tech debt, that it doesn't encapsulate, it doesn't stops at the core of the company. It will impact sooner or later and at different severity, but it will impact other other pieces of company. Okay, so we have got through what the tech debt is. So let's talk a little bit about how to manage it. So let's first try to identifying or how I can identify there is debt mismanagement. So since code is at the core, then engineers are basically the first people that could potentially notice issues, and there are always some issues. And if engineers don't raise them, then there is probably something wrong in our debt management. It's better if an engineer will notice a bug than a customer, after all. Second thing is that even if issues are raised somewhere, they are not really linked to this particular piece of code they are related to. This is something called trackability. So from a developer's perspective, I should be able to, when working on particular functionality or system, and getting into context of what relates to it, I should be aware, well, this piece of code, this function is a tech debt, and here is a link to a documentation that explains it better. Then there is no real review of the issues. Engineers never do it, never organize meetings where those tech debts are documented. And there is no discussion in wider scope. So as I said, okay, engineers should raise issues, but they are not the only people responsible for paying it off. That is very often business decision on which tech debt is more relevant to be paid off. And to make this decision, there should be some discussion on the backlog of tech debts. Then, of course, that is like more obvious. If our backlog is only growing and never really like at least kept on the same level, then there is some other indication of mismanagement. And finally, personally, my most important red flag is that there is no documentation at all. People know about stuff, but they don't share it. They don't document it. They don't talk about it. And very often I have seen such cases where there was a good expert, but he decided to leave a company for whatever reason. Maybe he was looking for new opportunities and places to grow. And then 2 weeks later, there's this big void of knowledge in the project. So we have talked about what could indicate we are mismanaging our tech debt. So a few notes about what we should actually do. So as I mentioned before, we have to remember that this is a scope of an entire team, not only engineers. So first, we have to ensure the visibility of the tech debt. When it is identified, it has to be written down somewhere. Personally, in my projects, it was usually either an epic task in Jira, or that was a Confluence that page that contained all the business details about particular tech debt. Then we have to ensure trackability, which is, as I said, when I'm working on a code, I need to know in the scope of this code, if it is a tech debt or not. So usually I simply leave a mark like to do, C, and add a Jira task number there. Next, we have to maintain inclusion. So the tech debt maintenance has to be an integral part of the workflow of the entire team. And that can be ensured, for example, by organizing meetings every 2 weeks or every month. And finally, we need to ensure assessment of the tech debt. So as the team may vary on a different level, there will be engineers, there will be some tech lead, there will be product owner, or sometimes a sales representative, or maybe even some important stakeholder. This assessment is important to make sure that people coming from those different perspectives understand the nature of that particular debt, root cause, and most importantly, consequences. Especially the consequences part is something where there'll be a lot of misunderstanding. From the engineering perspective, it will be usually something among those lines where I want to work with better code, where I don't spend as much time trying to understand it because it is so complex. And that's one consequence of the debt, that the code is complex. But the same debt will have another consequence from a product owner, that increased complexity raises delivery time, right? And the cost of new features will grow and grow. That is important for the sales team as well. This, because it will involve different parties, there will be always some kind of tug of war between them. But without an assessment, there is really no trying to getting into compromise. Usually when we try to understand other people's perspective, that also helps us prioritize one thing over another and get less frustrated about it. So those are for like my main bullet points on what should be ensured to have a good management. And I gave some samples. However, it is important to know that it will differ from team to team. There will be smaller teams, bigger ones. Each of them, like similarly to Agile, will work out their own exact strategies for debt management. So let's make a few notes about how to document a single tech debt. That is mainly coming from my personal experience as well here. So first, we should establish its type, mainly because it may answer us some questions like, if this is a build tech debt, then do we have a people, do we have anybody in our company that could help us explain it, that could help us paying it off in the future, maybe, right? It's not necessarily to point fingers. It's more of to who will be the best at managing this particular debt item. Next is about determining root cause. And again, it's not about pointing fingers. It's about realizing if the root cause may have some consequence. It could be, for example, that we have decided to use some old third-party system because there is this one important client of us that really needs it because for whatever reason, but the reason is still valid. And it may be that this tech debt is not actually something that we want to remove at the moment because of the dependency on that client. So next, we should go to the step of determining consequences. What is this assured cost? Maybe there is some maintenance that we are doing, the cost that we can actually try to measure. And we should establish all the risks that are coming with it, together with probability and severity of each risk. And we will talk about assessing risk a little bit on the next slide. Finally, we have to mark it. We have to document whatever we have done in those three previous steps and leave a trace in as closer to the product as possible. So in my cases, it was very often that there was this confluence. First, there was this epic in Jira that contained all the technical information about the tech debt. Jira page where it all the impact on the business was explained, as that was easier to talk about it with product owner, for example. And the Confluence page had a link to a Jira task. And then finally, the most important part was having a comment within the code that was linking to the Jira task. Optional step is trying to estimate resolution, but that is not always possible. Sometimes, yes, but very often it is a task on its own. Maybe we don't have a person in the company that has enough expertise to estimate the resolution. Maybe it is such a big task that it would require 3 to 5 days to tell, well, this architecture is so flawed, but nobody is going to propose a good one in 15 minutes during a tech debt review, right? That has to be a dedicated effort to estimate the resolution cost. And this one is also a very important piece of knowledge because trying to estimate the resolution sometimes might be pointless, especially if these are only engineers that would try to estimate resolution. If they don't know where a product owner is heading with the product, or what is the general strategy, or if there is maybe some particular, like with this case, a client that requires particular that requires particular solution, we consider a tech debt. There is really no resolution for that, right? So there has to be a full context, and this can be only assured during those reviews meetings. So last notes I will make is about risk assessment. This is a big topic on its own. We are not going to cover it fully today, but just so you know, it has its own ISO standard. And for the simplicity's sake, we will focus only on what is most useful, at least from my perspective. So there is trying to assess likelihood and severity. And it can be descriptive, like we estimate the likelihood is low or extremely low to almost surely will happen within next week. And then try assigning numbers to it. And similar to severity, low severity could be something like, I have to spend 5 minutes each day on making a workaround or something, to a very high. If we don't fix it within an hour, we can get a lawsuit. And in the end, they will give some matrix, which is basically multiplying likelihood with severity. The purpose of this is to give a vague look if some risk is actually really high or really low, and that will help prioritize paying off debt case by case. It's not like ideal estimate, but it's always better than nothing, that's for sure. And depending on needs in particular team or company, those assessments will differ. Sometimes where there will be 5 or more likelihood levels, and similar with severity. Maybe there will be different types of severity depending on if the impact is on team only or code quality only or directly to business. That's it basically about the theory and the management. So let's summarize it with some few keynotes. First, we have to ensure the communication between people in the team is clear and they are understanding the issues that are ongoing. We should have any process for documenting items, and the process should be also clear to everybody. The review and prioritization of existing items should be a regular work. It may be that something we today consider as a low risk, low severity, in 6 months will be a high risk problem because we have 10 times more users in the system. So any kind of data corruption could simply start being more probable to happen. Regarding those reviews, we have to make sure that all relevant stakeholders are in the discussion. If we have a tech debt that we assume will impact business, then there has to be somebody from the business side that will hear about this, that will be able to look at it from the business perspective and give an input on that. We need to have a monitoring system, and we should always addressing new items in some way, right? Usually by documenting them. And finally, all of that tech debt management will result in some experience, the experience we can use to prevent any further accumulation of the tech debts in the company, in the product. That's it. Here as a final note is a list of very useful sources that I have used for this webinar. I would especially emphasize on Step Size that have a lot of articles on their blog about the tech debt. I found it also very important. As I said, I'm a clean code enthusiast, but this position by Robert Martin really gives more glimpse on a fact that engineers don't work only on code. They work first with the team, and the team is a part of a company, and the company is a business. And this book gives a lot of this overlook that I'm not only a code producer, I am an engineer. I have to solve problems raised by business. Yeah. So those are my recommendations. And there are also some very good-looking papers from universities that are worth checking. So that's it. Thank you for your attention. And now it's time for questions, if there are any. So the question is every code refactory paying tech debt? So not necessarily. It might be that some refactor simply changes one risk for another. There shouldn't be a concept of ideal application because nothing like that exists. Today we have some priorities. In 6 months, those priorities can be changed. So the code will have to be in some way refactored again. The thing about the clean code that, as I understand it, is it should be as flexible as possible because the good code is the code that is suspect to changes and is easily changed. And if it is easily changed, then it can be repurposed for another stuff. So yeah, not exactly, but it's every refactor should have should be repaying some part of the tech debt. Maybe not everyone, maybe some new thing will be added. But most, I would also say that it's important to know that the code we write today may have different risks simply in the future. So that's why we have to review them from time to time. Next question is, if there is a new, better framework to do the same stuff, is not adopting this framework incurring tech debt? Well, that depends. And I think that is a very good case in the banking sector, where there are languages used that are older than me, in very old languages, right? And it's very old, and it is a tech debt, and it's a tech debt that banks are willingly not paying off because they estimate the risk of something going wrong as too high. So from their perspective, the cost, the profits they have of diminishing those risks is higher than the cost of maintaining all that old system. And that is also a good question about this perspective. So if there is a better framework, then is it good enough? Will rewriting everything to the good framework will bring enough profit to explain taking the debt? Because that will be some time, that will be some new stuff that we know we'll have to handle differently, and there is some stuff that we don't know we will have to differently. So that's a lot of this risk management rather than tech debt, I would say. Unless, of course, it is a situation where some framework or maybe even a language version gets deprecated, right? And then there is this question of when do I want to migrate, because I will have to eventually. And review of the tech debt is important here because for example, when there was a Python 2.7, when it got deprecated, nobody started migration to newer version right away. There was a lot of companies that waited. maybe in some cases, this was never migrated because the application simply died. And there was no reason of paying off that tech debt. It never rose to an amount that it would give impact on the product. So I hope that answered these questions. Okay, how much effort should be spent to repaying the tech debt? I'm assuming most libs and dependencies are regularly updated in the project. So this is the piece that we have to really discuss within our project. There can be different strategies. For example, dedicating 20% of our workload each sprint just to raising, to updating dependencing or doing some refactors here and there, or just trying or spending time to design better resolutions for the same problems, because after 2 years of getting the knowledge in some particular domain, we know it can be done better, but the resolution estimation that I have mentioned, it may take a while. So maybe those 2% of the workload will be enough for one team. Other teams will rather go with like a special release cycle when they work on a single release, which doesn't bring any new feature to the system, but only is focused on paying off the tech debt. That is actually something that happened with one of my favorite games, Europa Universalis, when after a series of adding new features to the game and adding new features, they finally went into a rabbit hole where lots of stuff starting falling apart. So then they took like a half a year, or there were like 3 months of full stop just to fixing all the bugs and paying off the tech debt, which in the next release resulted in providing more features than before this tech debt was paid off, because they were simply able to provide more with fewer resources. So it is simply a part of each project. Each team should agree on some strategy, and it will differ from team to team. So it's I don't think there is really any good indication of that. Do you know any company that follow all the rules that you presented? Is it possible? I think those are not very strict rules, and to some extent, we are kind of following some of them. There are people who make the documentation, but it might not be trackable, or there are proactive people in the engineers in the team that share this knowledge. There is a tech debt, it has this and this consequence, and project manager may say that, oh well, that is something that I should address to a business. And after a longer way, even if the initiative was not ideally following those hints, I would rather call them hints than rules, some tech debt will be actually paid off. And if I know any, well, I work in one, but it's not rather a company, it's a specific project that I work in. So I do have these epics that explain tech debts in technical details. They are marked if they code, although sometimes it is not exactly possible because the abstract of the nature of the tech debt is not really related to some particular piece, but rather an architecture. And every like 2 months or so, we are going through that tech debt, checking if anything has changed in a significant way. What we are actually not doing, and that is a big miss, is this better risk assessment. But that is always a work in progress. There is never a final state of strategy that team will follow. Okay, should there be a position in organization, example, tech debt manager? Similarly to before, I believe that in similarly like in Agile, there is not a position, there is a responsibility. So I think if the product is big enough, then it could be that there's a need for a tech debt manager. But that will have to be a person that knows the code very well, right, in the first place, and has some good overview on the product and what it provides and how the product can impact business. So other way, we could say, for example, that the CTO should take care of managing a tech debt. In other places, if the company is small enough, there will be only product owner, for example. It's more of like a person who will we assign this responsibility to. And it's not always, it's usually not a work on a one person to like spend 8 hours a day just doing that, managing tech debt. It's more about involving more people than dumping it all onto one. What was the biggest tech debt that you have experienced in your career? So the biggest tech debt was actually connected to data structure. I consider a database as being the most, the core of the core in the product, in the web applications. So if the data structure is allowing for inconsistency in the data, which simply doesn't reflect the actual truth in its domain, for example, it simply lies about some facts, then that's the most impactful tech debt, in my opinion. And it's really hard to pay off, because if it is a running application and let's imagine 5% of the records in the database may contain some kind of inconsistency, but it is a running application, people are using it, then how there is this problem on how can I add some more constraints to an already working application. That's, I think, the biggest tech that I have experienced. And the payoff strategy is kind of in progress. It's not a thing that we have decided to fix with 2 weeks amount of work. It's just rather tactical changes for some tables sprint to the sprint. So is tech debt just about DB design? No, absolutely not. That's just simply one of the examples. Tech debt could be not only about DB design, it could be code that is not incomprehensible. And like the most abstract example of that could be code that is written in different language than English. That happens from time to time, and that really increases the readability and the complexity of understanding the project. And that is even a people tech debt, because let's say if we are coding in Polish, then we cannot hire anybody from that doesn't know Polish language, because that person will have it so much harder to understand what is going on. We can have debt that is more related to very high coupling in the code, that I have seen also many times, there are simply no unit tests. There is only a functional test on the endpoint, and the endpoint does 100 different things. And if I want to reproduce something right now, then I have to spend a lot of time just to get to that particular deep piece of code that causes the problem. And the reason I cannot quickly narrow it down is because there was no unit test on this particular piece. So I'm not able to quickly understand what is the possible input and what should be the expected outcome in that particular case. How to convince a client to allow for more maintenance and documentation time instead of prioritizing another feature. So that the inclusion part of of those hints is very important here. If we will have, let's say it's a monthly meeting for an hour, 1 hour, when we will have an opportunity for engineer to explain to a product owner that I have a tech debt, and the risk of this tech debt is that we will provide security risk, and our data may or user confidential data may leak to the internet, or there is some, for example, case when we have a platform and one user could access assets of a different user. That's a business implication. And we as engineers tend to focus on the technical part of the tech debt. And that's why I not exactly like the tech in it. But it's very important to understand that the impact is on an entire company. And the product owner, when he will listen to that, and if you would have some prepared risk assessment, then that is that should be some data that he should understand, or she, right? That's why those meetings are important, to even have a chance of talking about it and only about it. If we don't talk, then there is simply not trying to understand each other, and that will lead to prioritizing another feature over the tech debt. I think the hardest part is not to talk about the debt when we have already documented it. I think the hardest part is about including the tech debt management as a part of our day-to-day work, of that regular workflow. And that will come down to simple reasoning. Like let's start with writing down some bullet points on, okay, we have this tech debt, this has these potential risks, and let's talk about it. What do you think about it? How do you think that could impact the business? Yeah, that is probably that is a very big topic on how to talk to the client. And for this one, I would recommend also this book about Clean Coder from Robert Martin, because he gives a lot of samples on how to be professional about talking our work and explaining how our technical implications will impact business. Okay. These were very good questions. So there are no more newer questions, but I will talk a little bit more about that relation between engineer and business then. As I said, that would be a great topic for another webinar. That is really something that I think we struggle the most with. And it's this soft skill that really is hard to grasp. It's not hard science when I'm able to tell you that 2 + 2 = 4, and we all agree on that. So it very much differs from a case to case. It differs from a team. If we don't have anybody that understands business within the team, that we may be stuck with this tech debt that is never prioritized, because there is nobody that would try to understand it, have a time to understand it. In the end, I think our responsibility as engineers is to be professional about our work, not be judgeful or not point a finger, simply state the facts that we as engineers can establish. So the fact is, for example, that library or framework is outdated. there is less and less people that want to work with it. So we will have some people debt in the future that will be raising. If it's not, if the framework is not maintained, at some point we will get a risk of diminishing returns. And it will be easier simply to write something in the new framework rather than sticking to COBOL. So this is the thing that we can provide, that we can write down, try to assess, and once they are written down, it's easier to talk about them with the people that are not engineers, right? Because business will usually understand risks even better than us. They might come up with idea, reviewing documentation that, well, out of those risks, I see yet another one that you haven't thought about. And that is because we don't have the same perspective as other people. Okay, we are nearing to an end, so and there is no more questions. So I think that will be it. Thank you very much for your attention, and have a nice day.